This video is fraction review from our basic skill review package, in case you're having a little bit of trouble remembering how to do fractions. So the question here asks us to simplify each of these without using a calculator. So if you have to use a calculator to help you with some of the multiplication, that's fine, but I'd like you to try to do some of the operations on your own without, having your calculator do it for you. So I have 2 over 3 times 4 over 5. Now, multiplying fractions is one of my favorite things to do because it's the easiest. All you have to do is multiply the numerators together and then multiply the denominators together. So here, we're going to multiply 2 times 4, which is 8, and 3 times 5, which is 15. And that's it. That's all you have to do. You just do top times top, bottom times bottom, numerator times numerator, denominator times denominator. So you should always look to see if it reduces at the end. However, they don't really have anything in common. 8 is only divisible by 2, 4, 8, and 1. And then 15 is divisible by 3, 5, 15, and 1. And dividing them by 1 doesn't really do anything. Dividing fractions is a lot like multiplication with one extra step. So instead of dividing, we actually turn it into a multiplication question. So I'm going to leave the 7 over 4 the way it is. But to divide fractions, we take this fraction after the division sign, we flip it over, and we multiply. So 7 over 4 divided by 3 over 2 is going to become 7 over 4 times 2 over 3. And then we just do numerator times numerator, which is going to be 14. And then denominator times denominator, which is 12. And then I always try to reduce if we can. So I notice that 14 and 12 are both divisible by 2. So 14 divided by 2 is 7. And 12 divided by 2 is 6. Now this is an improper fraction and we could make it a mixed fraction, but I'm just going to leave it for right now because what we need fractions for, we very rarely in this course will change them into mixed fractions. All right, the next one. I have 1/3 plus 5/6 minus 3/4. So to add and subtract fractions, this is where it gets a little trickier. You need to have a common denominator. So a common denominator is something that 3, 6, and 4 will all divide into. So in this case, my lowest common denominator would be 12, right? So I want to try to turn each of those into a denominator of 12. So what we're going to do is figure out what we multiplied the denominator by to turn it into 12, and then do the same thing to the numerator. So the first one, to turn a 3 into a 12, we had to multiply by 4. So to the numerator, we're going to take that 1 and also multiply it by 4 to get 4. Now the 6, to turn it into a 12, we had to multiply by 2. So I do the same thing to the top. 5 times 2 is 10. The 4, to turn it into a 12, we multiplied by 3. Same thing to the numerator. 3 times 3 is 9. And then once the denominators are all the same, we just add and subtract the numbers together. So 4 plus 10 is 14. Take away 9 is 5. Now we don't do anything with the denominator because we're looking at pieces that are all cut into the same size. So this is still just a 12. It doesn't change. So our answer here is going to be 5 over 12. Okay. Next question is a little bit trickier. Why? It doesn't have numbers. Well, it does have some, but it also has variables. So here we have a plus 5 divided by 4b divided by a plus 3 divided by 2b. So I'm going to try to follow the same steps we did with the division question up here. The only difference is I now have some letters to deal with. So when you are dividing, you take the one after the division sign and flip it over. So I'm going to get a plus 5 over 4b times 2b over a plus 3. All right, so what I'm going to do is multiply them together. But before I actually multiply them together, we're really just going to squeeze everything together. And I'm going to put all the single terms, the ones that don't have plus and minus signs, at the front. So when I squish these guys together here, I just get 2b times a plus 5 divided by 4b times a plus 3. Now, one of the things that I can do is if I have something that's the same on the top and the bottom, I can divide it out. And if I don't, then I can't. This a plus 5, there's an a plus 3 on the bottom. They don't match. If I had an a plus 5 on the top and an a plus 5 on the bottom, I could divide out a plus 5, a plus 5. But I do have a 2b and a 4b. So I can divide the top and the bottom by 2b. So I'm going to divide the top by 2b and the bottom by 2b. And what's going to happen here, 2b divided by 2b becomes 1. So I'm going to have 1 times a plus 5. Didn't really have to write the 1 there. And then 4b divided by 2b is just 2. And then a plus 3. And that's simplified. Now you don't have to put the 1. You could just have a plus 5 over 2a plus 3, and that's fine. We don't usually multiply it out. We usually like to leave it in factored form. That's a skill that's going to help us in our calculus portion of the course when we're doing some sketching, so we don't really want to ever multiply it out. We usually like to leave it in factored form. Okay, last two. So x plus 2 over 5 plus 5x over 3. So I'm adding, and to add I need a common denominator. So I have a 5 and I have a 3, so I want to try to pick a denominator that works for 5 and 3, which would be 15. So I'm actually going to write this all over one big denominator instead of splitting it up. I look at what did I do to the 5 to turn it into a 15. I multiplied by 3. So I did 3 times x plus 2, right, to that first one. And then there's a big plus sign in the middle, so plus. What did I do to turn that 3 into a 15? We multiplied by 5. Right, so I'm going to do 5 times 5x for the second one. I could have written these as 2 separate fractions. I just skipped a step by putting them all together into one. And then what I am going to do, I said not to multiply here because it was a final answer. I am going to multiply this out. So we're going to multiply the 3 into the bracket to get 3x plus 6. And then here, 5 times 5x is 25x. And that's still all over 15. And then I'm going to add. So 3x plus 25x, they're like terms, so I can add them together. So that gives me 28x plus 6 divided by 15. And then what we like to do is see if we can factor, if anything will simplify here. So I do notice that 28x plus 6 are both divisible by 2. So I can factor out a 2. And I'm left with 14x plus 3 over 15. Now, unfortunately, that 2 and that 15 don't have anything in common. The 3 and the 15 do, but this 3 is married to that 14x. They're a couple. So you can only cancel couples out with matching couples. And the singles like to mingle, so you can actually do the 2 and the 15 together, but they don't have anything in common. So I cannot reduce that. That's as low as it goes. That's all I can do. Now, last question. This one's the tricky one. I have 2 over a plus 3 minus 4 over a minus 2. So first thing, I need a common denominator. I have an a plus 3. I have an a minus 2. I can't really do anything with that except for just multiply them out. So my common denominator is going to be a plus 3 times a minus 2. What did I do to the first fraction? Well, I had to multiply by a minus 2. So we're going to have 2 times a minus 2. And then it is subtraction. And then what did I do to that a minus 2? I multiplied it by a plus 3. So we're going to do 4 times a plus 3. Now, this is an instance when I have addition and subtraction in between the brackets where I would FOIL it out, multiply it out, and collect up my like terms. So I have 2a minus 4 minus 4a minus 12. And that's still over a plus 3, a minus 2. Now the denominator is in factored form, so I'm going to leave it. But the numerator is not in factored form because of that minus sign in between them. So that's why I'm simplifying that. So 2a take away 4a is negative 2a. Minus 4 minus 12 is minus 16. And I still have that a plus 3, a minus 2. And then last step, I can factor that numerator by taking out a negative 2. And I'm left with an a plus 8. Unfortunately, that's not going to reduce, but that's okay. So I have a plus 3, a minus 2 in my denominator, and that's my final answer. And that is our fraction review.